closing error between A and A dash, that is E. The Bowditch's method consists of distributing error E among all the survey lines of the traverse according to their lengths. The lines of the closed traverse are laid out as a straight line and the ordinate A. A dash is taken as equal to the closing error E. By drawing one line each at every traverse point on the straight line, so that all the lines are parallel to A dash, the corresponding errors B, B dash to E dash are obtained. The lines B, B dash to E dash are drawn parallel to A dash upon the traverse with the closing error. The end points of these lines are marked B, C, D, and E, respectively. The traverse is then redrawn by joining A, B, C, D, E, A, so that the traverse adjustment is completed, without any closing error. So remember, by applying the Bowditch's method, the closing error is adjusted so that the ending point of the framework coincides with its starting point. In this module, you have learnt that traversing is a type of survey in which several connected survey lines of known direction and length form the framework. The importance of traversing is that it enables surveyors to accurately plot the shapes of ground features having an irregular outline. When the connected survey lines form a loop or a polygon around the ground feature, as in the case of a lake, it is called a closed traverse. When the connected lines form an unjoined pair along the ground feature, as in the case of a river or a road, it is called an open traverse. When the end of the last line of a closed traverse does not exactly meet the starting point of the traverse plotted on a map or plan, it is called a closing error. To rectify closing errors, some compass traverse adjustments, such as the Bowditch's method, are applied.
You have seen the errors that are possible when using a compass for land surveying. In order to avoid some of those errors and other mistakes which surveyors might encounter on the field, it is advisable to be aware of some do's and don'ts in compass surveying. So, what are these do's and don'ts in compass surveying which surveyors need to be aware of? Let's find out the answer by going through this module, Do's and Don'ts in Compass Surveying. Welcome. After completing this module, you will be able to list the do's and don'ts in compass surveying. The do's and don'ts in compass survey are basically a list of precautions to be taken in compass surveying. Let's find out what they are. To begin with, hold the compass in a level position always when fixing it to the tripod. Always tap the compass box after the needle has come to a rest to free the pivot of friction. Also, press the knob or pin to stop the vibrations of the needle. Don't bring metallic or electronic objects like keys and mobile phones close to the compass because the needle's movements will become affected. Then, remember to take the fore and back bearings of all the lines. When there is an obstacle between the compass and a survey station, always take readings from an intermediate point. Don't take readings from the wrong direction. Always take the duplicate readings at important stations to avoid errors. Let's summarize what to do and what not to do in compass surveying. These are some of the important do's of compass surveying that you must always follow. These are the don'ts that you must always avoid when using a compass.
You have seen that elevation at different points above a given surface can be determined by leveling. In order to determine the values of elevation accurately, we require the aid of some instruments. So, what are the instruments that help us to determine the values of elevation accurately? Let us find out the answer by going through this module, Leveling Instruments. Welcome. After completing this module, you will be able to identify the instruments for leveling. Two instruments that are required for leveling are a level and leveling staff. There are different types of levels and leveling staffs used by surveyors in the field. Let us take a look at what they are. The purpose of using a level is to find out relative heights. Any level consists of four parts: a telescope to sight objects on the ground, a level tube for making the line of sight horizontal, a leveling head to check and adjust the correct position of the device, and a tripod upon which the device is mounted. We can see these parts in the different types of levels, that is, dumpy level and Y level. The dumpy level is an optical instrument consisting of the following parts: telescope, eyepiece, objective, longitudinal and transverse bubble tubes, focusing screw, foot screws, leveling head, and screws for adjusting the bubble tube and the diaphragm. The dumpy level can be identified by its long, thin telescope mounted to the leveling head at one point between the three prominent foot screws. Now, let us take a look at the Y level. The Y level is an instrument with the telescope mounted in two vertical Y-shaped supports. Most of its parts are similar to that of the dumpy level. The Y level can be identified by curved clips that connect the telescope to the two Y-shaped supports. By raising these clips, the telescope of the level can be replaced with the position of its ends interchanged. So remember, the two different types of levels are the dumpy level and the Y level. The dumpy level can be identified by its long, thin telescope mounted at a single point, while the Y level can be identified by its curved clips. A leveling staff is used to measure the distance by which a given station lies above or below the line of sight. Basically, there are two types of staffs: a self-reading staff and the target staff. The readings of the self-reading staff can be read by the person using the leveling instrument, while the readings of the target staff must be taken by the person holding the staff. There are three types of the self-reading staff. Let us take a look at each of them. The three types of self-reading staffs are solid staff, folding staff, and the Sopwith telescopic staff. The solid staff is a one-piece staff made of seasoned timber. It is 3 meters long. The left side of the staff is graduated by meters marked in red, and the right side is graduated in decimeters marked in black. The smallest division on the solid staff is 5 millimeters. Now, let us take a look at the folding staff. The folding staff is made up of well-seasoned timber that is about 7.5 centimeters in width, 1.8 centimeters thick, and 4 meters long. It is divided into two parts of 2 meters, along with a locking arrangement. It can be folded into a shorter piece when required. It is graduated in the same way as the solid staff. Now, let us take a look at the Sopwith telescopic staff. The Sopwith telescopic staff consists of three parts, arranged such that the lowest one contains another extensible part, which itself contains the extensible third part. The two shorter lengths can be pulled from and pushed into the longest length, so this staff is called telescopic. While the top portion of the staff is solid, the middle and the bottom portions are hollow. The middle and top parts of the staff are held in position by spring catchers. So remember, the three types of leveling staffs are the solid staff, the folding staff, and the Sopwith telescopic staff. Module, you have learned to identify the instruments for leveling. Instruments used for leveling are a level and a leveling staff. The two different types of level are dumpy level and Y level. You can identify the dumpy level by its long telescope mounted at a single point between the 3-foot screws. You can identify the Y level by its curved clips that connect the telescope to two Y-shaped supports. Different types of staff are self-reading staff and the target staff. The three different types of self-reading staff are the solid staff, the folding staff, and the Sopwith telescopic staff. We have already learnt the leveling is the process of measurement of relative elevations of points in vertical plane by using a leveling instrument. Before measuring anything in the field using a leveling instrument, you need to make some temporary adjustments in the instrument. Let us see what the temporary adjustments are and how to make those adjustments. The procedure for setting up of leveling instruments is as follows. First, set the tripod on the ground over the station mark. Then, holding the instrument in one hand, Turn the leveling head of the instrument on to the tripod screw with the other hand. Spread the tripod legs to adjust the instrument to a convenient height. Then, drop a pebble from below the instrument on to the station mark so as to center the instrument accurately above the station mark. Now, fix any two tripod legs firmly into the ground and move the third leg circumferentially to bring the main bubble approximately to the center of the tube. So remember, the procedure for setting up of leveling instrument consists of fixing the instrument on the tripod, adjusting the height of the instrument and centering the cross bubble. Leveling up the instrument means bringing the bubble in the tube to the central position. The procedure for leveling of instrument is as follows. First, place the bubble tube parallel to any of the 2-foot screws. Bring the bubble to the center by rotating the 2-foot screws. Turn the bubble tube or telescope 90 degrees so that it lies over the 3rd foot screw and exactly perpendicular to the first position. Bring the bubble to the center by rotating the 3rd foot screw. Bring back the bubble tube to the first position, that is, parallel to the 2-foot screws, and check whether the bubble remains in the center position. If not, center the bubble again by rotating the 2-foot screws. Repeat the same process till the bubble remains in the center of the bubble tube, whatever be the direction in which the instrument is turned. So keep in mind, always follow these steps for leveling up of the instrument. For accurate sighting, parallax should be eliminated. It involves two operations such as focusing the eyepiece, turning the focusing screw. For focusing the eyepiece, look at the sky or white sheet of paper through the telescope and focus the eyepiece until the crosshairs are clear and distinct. Now, for turning the focusing screw, look at the staff through the telescope and turn the focusing screw till the image appears clear and sharp. Always remember, parallax is eliminated in 2 steps, focusing the eyepiece and turning the focusing screw. A permanent benchmark refers to a point with a known elevation above mean sea level, MSL. Usually, the permanent benchmark is far away from the site of the survey. In such cases, a piece of land or a pillar or a bridge can be considered as temporary benchmark. The elevation of the temporary benchmark is assumed to be 100. To know the difference in elevation between a given point and the temporary benchmark, first place the staff on the temporary benchmark and take the reading with a level. Note that you have to add 100 to this reading. Next, place the staff on the given point and take the other reading. the difference between the reading of the staff at the temporary benchmark and the reading at the given point serves as the transferred benchmark reading. In this way, the benchmark can be transferred from the temporary benchmark to the given point. The process is called transferring the benchmark from one point to another point. In this module, you have seen the types of adjustments required for leveling instruments and to transfer the benchmark from one point to another. The operation of temporary adjustment involves three major steps, such as setting up of the leveling instrument in field, leveling the instrument, elimination of parallax. To transfer the benchmark from one point to another, subtract the reading of the staff at the given point from the reading of the staff on the temporary benchmark. You have seen that elevation at different points above a given surface can be determined by leveling. Do you know, depending on the requirements of the survey and the ground features, leveling can be carried out by different methods? So what are these different methods of leveling? Let us find out the answer by going through this module, Methods of Leveling. Welcome. After completing this module, you will be able to state the various types of leveling, explain the circumstances under which they are used, and their importance, plot the profile of a ground, and plot the cross-section. The various types of leveling are differential leveling, profile leveling, cross-section leveling, reciprocal leveling, and precise leveling. Now, let us know about the circumstances under which each of them is used and the importance of each. Differential leveling is used when we need to know the difference in the elevation between 2 points, whatever be the relative horizontal position of those points. Differential leveling is important as it helps us in tasks like finding out the difference in elevation between places like adjacent towns or cities. Profile leveling is used when we have to find out the elevations at several points on a line at fixed intervals of distance. Profile leveling is important as it helps us in the planning of structures like railway tracks, canals, water supply, and sewerage lines, etc. Cross-section leveling is used when we have to find out, on both sides of a main line, levels that are perpendicular to that line, so that we can find out the vertical cross-section of the ground surface or of the layers underground or of both. Cross-section leveling is important for projects like road carpeting, excavation, etc. Reciprocal leveling is used when we cannot set up the level at any intermediate position. Reciprocal leveling is important when we are carrying out leveling over ground features like rivers and valleys. Precise leveling is used when a high level of accuracy is required. Advanced leveling devices are used to carry out precise leveling. Precise leveling is important in the planning of buildings, dams, industrial plants, etc. So remember, these are the various methods of leveling and their importance. You have seen that profile leveling helps you to find out elevations at several points at fixed intervals of distance along a line on the ground. In order to plot the profile of the elevation of the ground at each such point, a graph can be plotted, with the points taken along the x-axis and the elevation at each point taken on the y-axis. By joining the dots corresponding to the elevation at each point, we get an idea of the profile of the ground. You have seen that cross-section leveling is used when we have to find out the vertical cross-section of the ground surface or of the layers underground. In order to plot the cross-section of a ground, we can take the chain edge points along the x-axis and the elevation at each such point on the y-axis. By joining all the points of elevation, we can get an idea of the cross-section of the ground. Reduced level means the vertical distance between a given point and the surface of the benchmark or other reference level such as the mean sea level. There are two methods for calculating the reduced levels: height of instrument or height of collimation method, rise and fall method. In the height of instrument or height of collimation method, you measure the height of the instrument at every station. Reduced levels of points are calculated by subtracting the foresight or intermediate sight from the respective height of the instrument. The difference of the sum of backsights and the sum of foresights must be equal to the difference of the last reduced level and first reduced level. This is how you can carry out arithmetic check by the height of the instrument or height of collimation methods. The rise and fall methods refers to the difference of level between the two consecutive points. It is determined by comparing such points after the first with that immediately preceding it. If the result is positive, it falls under the rise column of the field book, and if it is negative, it falls under the fall column. When you have all the readings in your field book, you need to calculate reduced level by subtracting the fall from reduced level of preceding point. Once you have found the reduced level, you need to check the correctness by arithmetic check method. Thus, the height of instrument or height of collimation and rise and fall methods are used to find the reduced levels in the leveling survey. Typically, a level field book contains the columns such as backsight, intermediate sight, foresight, height of the instrument, rise, fall, reduced levels, and remarks. There are two methods for calculating the reduced levels: height of instrument or height of collimation method and rise and fall method. In the height of instrument or height of collimation method, you measure the height of the instrument at every station or field. Reduced levels of points are calculated by subtracting the foresight or intermediate sight from the respective height of the instrument. You have seen that elevation at different points above a given surface can be determined by leveling. Sometimes, though, the ground features are such that the task of leveling runs into problems. So which ground features cause these problems, and what are the problems of leveling? Let us find out the answer by going through this module, Problems in Leveling. Welcome. After completing this module, you will be able to solve the problems in leveling.
नमस्कार, आपका स्वागत है इस लैंग्वेज के पहले अध्याय में। मैं हूं आपका प्रशिक्षक कौशल किशोर शर्मा, प्रधान तकनीकी अधिकारी सीडेक पुणे।